In this part of our linear equations chapter, we're going to look at applications of linear equations or word problems. And I'm going to actually split this video into two different pieces for two different types of problems. So let's start out by looking at the top of your notes. It says solving translation problems involving one unknown. So we're going to start out with translation problems with just one unknown. So if you'll remember from a prior video, translation problems are where we take words and we turn them into algebraic symbols, either expressions or equations, and these will be equations. So it says twice a number added to 7 is the same as 3 subtracted from the number. It sounds like a lot of words, doesn't it? Find the number. Now, I added some extraneous commas to this to separate clauses to help you see better how to translate on this first one. So the first step we want to do is what is called state your variable. So we're going to say let n equal the number. And I know that may feel awkward to you, but it's necessary on these problems to always state your variable. And that's what we're looking for, so that's what we're letting our variable represent. Now we go back up to each clause and we are going to translate. So first we have twice a number, and so we know that n is our number, so we're going to write twice a number means 2n, or 2 times n. Then it says added to 7, so plus 7, is the same as is equals 3 subtracted from. There's that word from, where we know that the order of the words doesn't match the order of the translation. So 3 subtracted from the number. So the number with 3 subtracted from it. And we have our equation, and that's actually the hardest part of this kind of problem. Now all that's necessary is to follow the steps of solving, get rid of fractions, distribute, combine like terms, get variables equal to numbers, and finally divide. There's no fractions, no distributive property, and looking at the left side and then the right side, there are no common terms on either side, so we can't combine like terms. So my first step I actually have to do is to get variables equal to numbers. So I'm going to subtract this 1n, and if it helps you to write 1n, go ahead and write that. We know that that's how many n's there are. 2n, take away 1n, is 1n plus 7. That zeroes out, 1n minus 1n, and we still have a negative 3. Don't forget that negative sign. Don't accidentally drop it. Now I have my variables on the left, so I need my numbers on the right, and I'm going to move them by subtracting a 7. That makes a 0. 1n is just n, and I have negative 10 when I combine those. And we have solved our own equation. Let's look at another one, a little bit different. The wording in this one's going to feel different. Heather put some money aside in an envelope for small household expenses. Yesterday she took out $20 for groceries. Today a friend paid back a loan, and Heather put the 34 in the envelope, and now she has 43. How much was in the envelope at the start? That is what we are looking for. So we say, we'll use x this time. Let x equal the start amount. So I'm going to kind of abbreviate this. The start amount. So she started with x, and then let's look at what happened. She took out $20. So that would be minus 20. Then she got paid back a loan, and she put 34 in, so that would be plus 34. Then it says now she has, that would be equals 43. So our start amount minus 20 plus 34 back in equals 43. And all we have to do is solve for x following our steps that I listed up here. I'm not going to write them again. There's no fractions, no distributive property, but there are like terms on this side to combine. A negative 20 and a positive 34 gives me x plus 14 equals 43. The X is already by itself on the left, so I have to get my numbers on the right. And I get X, that zeroes out, equals $29. So that means that she started with $29. Now this is an easy one to check, because if she started with 29, she spent 20, that gives you 9. She added 34, that gives you 43. So it's an easy one to reason through. This next one is quite a bit harder, and it's just because of the way the words are. So you just have to kind of get used to this. It says Susan donated 10 more than twice what Luann donated. Do we know what Luann donated? We don't. So what Luann donated is going to be our N. So let N equal what the amount of money that Luann donated. And I think that's kind of hard to pick out of the problem. Now we have to translate Susan donated 10 more than twice. So the amount that Susan donated is the other thing we need to know is 10 more than twice Luann's donation. But what is Luann's donation? It's N. So it's 10 plus 2N is what Susan donated. Now it also tells us that Susan donated 22. So I know that that equals 22, and I now have my equation, and that is 10 plus 2N equals 22. So this one is quite different. We'll solve that. There's no fractions, distributive property, no like terms. So I'm going to get the variables on one side, numbers on the other. I get 2N equals 12. I divide by 2, and I find that N equals $6. Now what did we just find? What you do is you go back to your let statements where you declared your variables, stated your variables. And you say, well, what was N? N was the amount that Luann donated. So we found what we were looking for, because the question was, how much did she donate? So she donated $6. And we already know that Susan donated 22.